Students, we will discuss sample space. Today we will discuss sample space in probability. Right? What is the definition of sample space? Come to definition. It is the set of all possible outcomes of the random experiment. Right? It is the set of all possible outcomes of the random experiment. All possible outcomes means maximum outcomes. Okay. Random I have explained in previous episode meaning of the random experiment. Okay. So now come to example. Example 1. Toss a coin once. Okay, and I am showing by practical. Toss a coin once. You see, this is the coin, unbiased coin. I got head, right? I got head. I got tail, right? I got head. Okay, so head, tail will be repeated. There is no necessity of writing head and tail repeatedly, because you know in set theory the elements of a set are not repeated. Okay, so the toss of a coin once, the sample space will be what? The set having the element H and T. HT. And example 2, come to example 2, toss a coin twice. Toss a coin twice. You see, okay, I got tail, right? Tail. I got head, tail head. Okay. Okay, this is one outcome, right? And I have completed one experiment. Okay, I got, you see, head, right? I got tail, head, tail, right? So I completed. Now I have completed second experiment. HT. HT is the outcome. HT is the result. Okay. Similarly, you can get all the outcomes. That is HH, HT, TH, TT. So sample space will be this. Okay. Then come to example 3. Toss a coin thrice. S will be what? HHH, HHT, THHH, like this. Then come to example 4. Toss 2 coins once. Toss 2 coins once. Okay. I got head. You see, I got head. Okay. Now I got tail, right? Tail. Okay. Similarly, you can get HT and TH. Okay. Then come to example 5. Toss 2 coins twice. You will get HHTH, HHHH, like this, TH. Okay. Total 16 elements you will get. Right. Example 6. Come to throw a dice once. Throw a dice once. I got, you see, 6, right? 6. I have completed one experiment. Okay, come to next experiment. I got you see 2, right? Here 2. Okay. So similarly, you can get 1, 3, 4, 5, right? So sample space will be a set having elements 1, 2, 3, 4, 5, and throw a dice twice like this. Okay. Sorry, one has been stolen. One has been okay. Then come to, so similarly you can get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2 like this. Okay. So sample space. Very important thing is you can understand what will be sample space, what will be maximum outcomes by your intellectual level. If you do not know in your intellectual level, you will have to do practical. Okay. So by the practical you can confirm the maximum outcomes, right? Then comes to another important point is application of counting principle. So how we apply the counting principle in probability to get the outcomes, to get the sample space, right? You see in the here the set A and B, two sets are, I have taken two sets, A set having the element A1, A2, A3 up to AN and set B having the element B1, B2, B3 up to BM, and making choices from A to B. Okay, A to B. That means A1, B1, A1, B1, A1, B2, A1, BM. Okay, then A2, B1, A2, B2, A2, B3 like this. Last one AN, B1, AN, B2, AN, B3 like at last AN, BM. Okay, so how many choices will be available? That means here you see, here M choices, here M choices, here M choices, like this total number of rows, what? 1, 2, 3, like n rows. Okay, so total number will be M plus M plus M plus M plus up to n times, right? Up to n times, that is equal to M into n. Okay, this is the counting principle. So the application of counting principle in a probability, you see, toss a coin twice or toss two coins once. The two experiments are similar. That is why I have given oblique mark. You see, a coin is when toss a coin twice. You see, a coin HT, another coin HT, like this. So HH, HT, TH, TT. Okay, these are the outcomes. So by counting principle, so number of outcomes will be what? Here 2 elements, here 2 elements. That means 2 into 2 is equal to 4. Okay, right? Come to application of counting principle. When the experiment is like this, throw a dice thrice or throw 3 dices once, right? So how can we apply the counting principle to find the maximum number of outcomes or the number of elements of sample space, right? Here I have taken one dice A, and second one is B, and third one is C. Here you know 1, 2, 3, 4, 5, 6 possibility. B 1, 2, 3, 4, 5, 6. C 1, 2, 3, 4, 5, 6. Right? So sample space will be 1 1 1 1 1 2 like this. Last one is 6 6 6, right? So total number of outcomes will be what? 6. Here are 6 elements, here 6 elements, here 6 elements. That means 6 into 6 into 6, that is equal to 216, right? So this is the extension of counting principle. You can apply more than 2 sets, more than 2 cases, okay? So this is the extension of counting principle. In case of counting principle, I have said for only for 2 sets A and B, you can apply also up to n times, n sets A, B, C, D like this, okay? So then comes to for coin. So number of outcomes will be 2 into 2 into 2 into 2 like this n times. Condition is what is the experiment? Then throw a coin what? N times, right? Throw a coin n times or throw n coins, right? N coins once. In that case, so number of outcomes will be 2 into 2 into 2 into like this n times. This is by counting principle, that is equal to 2 to the power n. In for the case in case of dice, similarly throw a dice n times or throw n dices once. In that case also, the number of outcomes will be 6 into 6 into 6 like this n times, that is equal to 6 to the power n. So we have applied counting principle. Okay, later time we will discuss about the past coin. We will discuss about cards. Okay, you can understand later time. Okay, bye. Thank you.